Hi guys. Now, one of the things that we're talking about here is science as a whole and how science is different from other things, in particular, how it's different from pseudoscience or non-science. Now, you can go through a ton of different definitions for this, but ultimately, science can be defined in typically one of three ways. The first is it's a state of knowing. Knowledge is distinguished from ignorance or misunderstanding. So, really, it's the fact that we know something about something that's concrete. When we say concrete, we'll talk a little bit more about this later, but it's the ability to be able to reproduce something through multiple iterations, typically by testing. Another definition that commonly comes up is a branch of knowledge or study dealing with a body of facts or truths systematically arranged and showing the operation of general laws. Now, this is what most of you think of when you think of science, because you think of science in terms of science class. It's this collection of material that you learn and that you have to memorize and regurgitate on a test at some point to be able to go ahead and pass and move on. But this is not what I want you to think of when you think of science. When you think of science in this class, we really want you to think about this as a process. Okay? It's a process where we gain knowledge of the physical or material world through observation and experimentation. And you can apply this in much more varied ways than just science class itself. You can use this when you diagnose a problem with the engine of your car, when you find a problem with your tire and you need to repair it on your bicycle, when you choose what college you go to, when you go ahead and decide whether or not to join a particular club or sport. You list out what it has, what the observations are that you can make, isolate facts, and make a decision based on the information that you have. This is really what science is. So I want you to think of science as a way of thinking. And this is based on a great science communicator, the late Carl Sagan, who gave us the original cosmos. He once said that science is a way of thinking much more than it is a body of knowledge. And that's really what I want you to think of as we go through and approach science class this year. Now, I also want you to kind of recognize what science is not and how to be able to tell the difference between what is scientific and what is not scientific. And what I want you to think of as we go through is kind of be able to think about this definition of science as a way of thinking. The one that I want you to kind of keep in mind and might want to include in your notes is that science is the systematic observation of natural events and conditions in order to discover facts about them and to formulate laws and principles based on these facts. Okay, so that's the working definition I want to start from. And we can separate those things that are science from those things that aren't science by using a criteria set. In this particular case, I want to look at 6 criteria that separate science from non-science. That criteria uses the acronym COMPT, C-O-N-P-T-T. Consistent, observable, natural, predictable, testable, and tentative. Okay, so what does each one of those mean? Let's go over that really quickly. Most of you hopefully know what the word consistent means. Consistent means something that can be repeated. These types of observations that can happen again and again and again and have the same thing occur. So if I were to go ahead and lift up my textbook and I'm dropping it, what would you expect to happen? Most of you would say that it would fall. So if I let it go, yes, it fell. What if I do it again? It fell again. What if I did it again? It fell again. What if I did it again? Okay, so you get the idea. It consistently happens. But what if this time when I dropped the textbook, instead of it falling, it floats in the air? Okay, think about that. We'll come back to this. Okay, so Consistency means it's something that happens again and again and again. And if we have trouble with it happening again and again, we have to be able to explain why. Now, how did you know that the textbook fell? Well, I can tell by seeing it, but you could tell by hearing it. Okay? Either way, we are making an observation. We, when we make observations, are using our senses, okay, or extensions of our senses. So we'll talk a little bit about when we look at cells that we use microscopes. That's an extension of our vision. When you use things like a telescope, same sort of thing. Maybe we use something like a Geiger counter or some other tool that extends the range of our senses, okay? These help us to make observations of the world around us. Now, N, natural. This gets a little bit tricky. When we go through natural, most people say, well, what is not natural? So, oh, this desk is not natural. Well, is it? The natural part of this desk is that it's made of materials that we know something about, and it behaves in a way that we can go ahead and predict. When we say natural, we're not saying natural versus man-made. We're saying natural versus supernatural, ghosts, goblins, these types of things. If you need to explain that something happens because God did it, then you are not really doing science. Okay? Doesn't mean it's incorrect. It's just not testable. So we'll talk more about that later. But when we say natural, we're existing in the realm of the explainable, okay, using our natural world around us. Okay, so it's in the realm of science. It doesn't mean it's not true if you can't explain it with science. It just means that you are not in the realm of science itself. Okay, so C-O-N-P is next. P is for predictability. Science is not very useful if you can't use it to predict what is going to happen next. Now, when I held up the textbook and told you I was going to drop it, you were able to predict that it was going to fall, okay? Because you know that gravity exists and you know that it has an effect on objects that are not held up. When we go ahead and do that, we are using this aspect of determining science, that it is predictable. And we want to be able to use those predictions to determine what's going to happen next. All right. The next one is the first of the two T's, testable. You always hear in science that there has to be an experiment or some mode of testing what you think is going to happen versus what actually does. Okay, so testability, you're dealing with some process of being able to evaluate what you think is essential for this to occur versus what can cause this to occur. And so we think about testable as being this kind of concrete piece of evidence that can help tell us whether something is scientific or not. Now, this gets a little bit tricky when we start thinking about fringe science or what they call theoretical science. Now, theoretical science is something that cannot yet be tested. And so according to this definition, there are certain things that we think of as very scientific that are not technically in the realm of science. A great example of this would be a black hole. Now, most of you have probably heard of black holes, but what exactly is a black hole? Well, somebody can say that's a dense well of gravity that sucks anything in. Well, what happens inside of the black hole? Unfortunately, nobody can really give you an answer to this question because none of the materials or abilities that we have allow us to observe beyond what is called the event horizon. So when you have movies like Interstellar, which is a great movie, by the way, and they go ahead and give an example of what is occurring inside of the black hole, inside beyond the event horizon, this is all theoretical. At this particular time, we cannot test it. But that doesn't mean it's not valuable or valid. When we start thinking about Einsteinian relativity, when Einstein first came up with it, this was theoretical. But it gave us a place to head towards, and we now have been able to test Einstein's theory of relativity and discovered that it is concrete and that it is testable and verifiable. Okay? So testability is a key piece of the scientific problem, but we have to realize that you only can test it if you have the ability to observe it and control parameters and these types of things. And that doesn't mean it's not valuable if it's not testable, but it doesn't technically fall into this realm of true science or applied sciences. Instead, it is in a realm of more theoretical science. And the last T is tentativeness. Now, some of you may already know the word tentative. When we say the word tentative, what we're thinking about is that it's not set in stone. If I were to go ahead and ask one of you out to lunch or to a cup of coffee, you'd say, yeah, we have tentative plans to meet up and do that. That doesn't mean it's guaranteed to happen, but the plan is to have it happen. One of the strongest pieces of the scientific process is that it's not set in stone. Let me give you an example. Now, we all know that the earth is flat, right? What? We don't? Well, for the longest part of history, we actually did think the earth was flat. Okay. So the earth's not flat, but we are at the center of the universe, right? What? We're not? But again, for the longest time, we did think that we were. One of the beautiful things about science is that as time goes on and we collect more data through tests, right, through experimentation, and we establish more facts, we develop a better picture of the natural world around us, and our understanding of that world changes. Scientific theories are constantly modified as we develop new observations and get better skills or tools to allow us to examine the world around us. So what we knew in the past doesn't necessarily hold true for the future if the facts or data sets do not support it. Sometimes it's a small tweak. Other times it's a whole restart. But these are the big things that help us separate science from non-science. And one of the things that I've always struggled with is this big dichotomy that separates science from religion. In many respects, science never claims to go ahead and explain those things that fall into the realm of religion. Science is something that follows COMPT, C-O-N-P-T-T, consistent, observable, natural, predictable, testable, and tentative. All right, guys, I hope that makes some sense. Please let me know if you have any questions, and we'll go ahead and move on from there. Bye.